If you check the number of views and you see there's very few, that's because this is a brand new recording with a brand new Algebra 2A Unit 1-1 through 1-3 quiz review. So let's go. I got my highlighters, I got my eraser, and I got my handy dandy Ticonderoga. What else do you need? So let's begin. So for 1 through 9, use the following graph, this graph. Assume x and y intercepts are whole numbers. That's huge. All right, first of all, domain. Domain is how far left does the graph go, how far right. And it's saying use interval notation whenever possible. So, how far left does this graph go? Well, it wants to get to -5, but notice it's an open circle, so that's a parentheses, -5. If that was filled in, that'd be a bracket. How far right does it go? Again, open circle, 5. So, that means it's a parentheses. Range. Range is different. How low does it go? And again, you see that it gets to -3. And yes, you can assume it gets there. So we're going to go -3 with a bracket, because that's like a closed-in circle. And then how high does it get? What's the peak of the mountain? It's right there, which is 1, which is another bracket. X-intercepts, you just go along the x-axis. There's one, -2, 0. And here's another one, -4, 0. Y-intercepts, there's only one. That'd be 0, -2. All right, here comes some precise thinking. Where is the graph positive? Well, a positive means above the x-axis. And that's the only place. Now here's the twist. This point, the x-intercepts are not above the x-axis, so it's like it turns them into open circles. So the only place that's above the x-axis, and again, when you're talking about the intervals, you're really talking about the domain. You let go of the range. So how far left does this graph go, and it's above the x-axis to -4? But it doesn't include -4, because -4 is actually on the x-axis. Same thing with -2. So that's why we use parentheses. If you use brackets, technically you're wrong, so be careful with that. All right, where is the graph negative? We're going to use a green marker. I can see that it's underneath, that's what negative means, underneath the x-axis right here and right here. So I know there's two chunks, which means there's going to be that U, which means together with or in addition to. And so I need to explain how far left does this little chunk try to get to -5, but it's an open circle. How far to the right? Again, it's -4, but it doesn't include it because that's actually on the x-axis. It's not below it, it's not above it. So that's why we use parentheses. And now another one starts at -2, but it does not include -2. And then it goes all the way to that point, which is 5, but it's an open circle. So parentheses. All right, increasing and decreasing questions, these two, you got to move left to right. You got to remember that for these increasing, decreasing problems. So I'm going to get out a different colored marker. Increasing means as you're moving left to right, you're going up. Well, that's definitely there, and it's definitely there. So, where is it increasing? Well, there's two places, so I need those at U, which means union, technically, from -5 to -3. All right, so -5 to -3. Now, the question is, do I use a parentheses or bracket here? But we decided if you're on a trampoline and you bounced up, you'd be at the state of equilibrium there. You're not going up, you're not going down, so therefore we decided to go with parentheses. So that's kind of our explanation for that. But there's another space from 1, and again, we're going to go with 1, because it's like state of equilibrium, starts right there, and then it goes up to here, which is, goes up to here, but we got to think about left to right stuff. I almost got sucked into thinking about range, but from -1 all the way to 5, open circle. or is it decreasing? I got one more color, blue. Well, that's decreasing all the way through here. So we need to talk about the domain. Where is it decreasing? So it's from -3 all the way to 1. When you're doing increasing, decreasing, it's very easy to start thinking about range, but you got to prevent yourself from doing it. It wants the domain where it's increasing and decreasing. Rate of change, what's that another phrase for? Slope. What's slope? Rise over run, and this is a formula. Now what is this? Now this is a fancy way of saying there are 2 points. One of them is where x is -1, and the other one is where x is 1. And we need to observe the graph and look for the point where x is -1. Well, it's right here, and there's the point on the graph where x is -1, so y would also be -1 in that case. But where x is 1, which means go to the right, find the point on the graph, and it's right here, which is down 3. So this weird interval notation is a secret way of explaining, hey, there's 2 points, and that's what that represents. So if you wanted to, from -1, 1, which is right here, I'll make a great big bubble, and 1, -3, which is right here, you could just eyeball it and go rise, which is 2, run, which is, and this is getting messy, but -2. I could go rise over run, which is -1, and say, hey, there's my rate of change, slope. Different students like to be more formula guided, so maybe you want to use this and use this formula. So what's y sub 2? -3. What's y sub 1? -1. Careful those double negatives. x2, 1, x1, -1. So it's -3 plus 1, which is -2. 1 minus a -1 is 1 plus 1, which is 2, which is giving me -1. All right, there we go. Let's keep going. That was a lot. So it says if f of x equals x squared minus 3, which is like a nice little lesson, because that's like taking the parabola, we know that from this, dropping it down 3, and you can see that's what's happening. What does the graph of f of x look like if it's reflected over the x-axis? Well, anything below the x-axis is going to go above it, and I'm being very non-perfectionistic here, but everything above the x-axis is going to drop below it. So it flips over the x-axis. That's what it means. All right. So, and let's keep this thing going. So we're up to number 11 already. And I'm going to move quite quickly here, so get ready. So it says sketch, doesn't need to be perfect, the function as a translation of the parent function. Well, we look at this and we go, wait, I remember the parent function looks like this. So I'm going to do the parent function in pencil, which it doesn't say to do, but I like to do it. And then I'm going to make the adjustment with a marker. So what does this do? Well, this is my D. And remember, guys, this is all based on your little rules that I gave you. Now, a lot of students get confused, like, how do you know that's D? Well, C is on the inside of parentheses, but it's also on the inside of absolute values, and this is not on the inside, it's on the outside, so it's D, which means we got to go down 2. So that would look like that. All right. Same thing. What's my parent function? Y equals x squared. So I'm going to just like sketch y equals x squared. And then I'm going to remember, wait a minute, this is C. And if it's plus 1, that means left 1. So I got to move this guy left 1, which these little squares are so small that it's not going to look like much of an adjustment, but there's left 1. Okay, 2 ways you could do this problem. Number 1, you could use the rules as the translation, because that's what they want you to do. So you could go, aha, my parent function is y equals x, which looks like this, and I'm going to perform 2 things on it. Vertical stretch 2, up 3. So if I went vertical stretch by 2, it would double everything, so it would be going up faster. Again, this is just a sketch, but then I still need to move it up 3. So that one, which is more steep, goes up 3. 1, 2, 3. And I just try to duplicate that to the best of my ability. Okay. What's another way you could do this problem? Well, don't use the parent function. Just graph the line. This is my y-intercept. This is my slope. So I'd take that original line, y equals x, and I'd say, hey, my new y-intercept is 3. 1, 2, 3. From there, I'd go slope. I know I made it messy, but it's 2 over 1. So I go up 2, right 1, and then I'd get the same thing. So 2 ways to do those. This one, again, y equals x squared is my parent function, so I just draw it. If my a is 2, that means there's going to be a vertical stretch. Now, that means it's going to go up faster, which means it's skinnier. And there we go. Last one on this page. Y is the absolute value of x. Well, by memory, I hope you know your parent function looks like this. This is simply a vertical shrink, which means it doesn't go up as fast. So there you go. So just kind of get in the ballpark. All right, now you're going to use your words. So all these words we're going to use here. So you don't have to graph. So what does that do? Well, again, this is y equals a bx plus c plus d stuff. And I'm not going to write all the rules. You can look in your notes. But if a is a whole number greater than 1, that's going to be a vertical stretch. It's going to go up faster by 2. And that's going to move it right 3. This one, no matter what it is, even so, that's my a. That's less than 1, so that's a vertical shrink. If I had a certain amount of money and I only could keep 1/4 of it, I just shrunk my money. Okay, that's why you have to think. This one I'd double it, so I'd stretch it. All right, but I have to go left 1, and then this one takes me down 2. Uh-oh, we got a negative in our A, so that's a reflection over the x-axis. And then this guy is D, because it's not inside the parentheses. If it was inside parentheses or absolute value, then it would be C, but this is D, so that'd be up 1. This one, same thing here, reflect over the x, but then we have a vertical stretch 2. That is a negative B. So that means that reflects over the y-axis. And then this rule is I need to go right 2. All right, believe it or not, we're almost done with this review. All right, so we got this piecewise function. So we're going to start with this, just graphing it. I'm going to deal with this later, deal with that later, but let's get this done. So really we got 3 functions. I'm going to try to squeeze them in here. So what we have is we have y equals 4x plus 11. In other words, y equals this. But I also see the outside limits of the function. They want me to consider x is negative 10, far left. I'm going to give myself a little clue and fill in the dot, knowing that my outer boundary is going to be a filled-in dot. But I also have less than or equal to negative 2, so I'm going to put that in for my x, and that's going to be a filled-in dot too. So negative 10 times 4 is negative 40, plus 11 is negative 29. Put the negative 2 in. That'd be negative 8 plus 11 is 3. So I don't know if I can fit this in. This is so blurry, but negative 10 looks like 7, 8, 9, 10. Negative 29, I mean, I'm just going to put it way down here. That could be way off, but I'm just going to put it there. And then negative 2, 3. Negative 2, 3. Looks like that's a, oh boy. 1, 2, 3, 4. Let's just go with that. So, negative 2, 3 would be right there. And I'm going to do my best to draw a straight line. And there we have that piece of this function. So now we got to move on to this. So I'm going to move it over here, y equals x squared minus 1. Now the first thing you need to think is this is a parabola. Notice this was a linear function. We only needed 2 points and everything's good. This is going to be a little more challenging. I'm going to try to explain myself. So there's my x and my y's. Let's find the far left boundary is -2. And because it's greater than or equal to, it's going to be a filled in dot. Less than or equal to 2. But if I only use 2 points, we're going to have a problem. -2 squared is 4. 4 minus 1 is 3. 2 squared is 4. 4 minus 1 is 3. So I'm going to plot these 2 points. -2, 3 is right there. Let's repeat. 2, 3 is right here. Now, if I went, oh, so there it is, you're forgetting that the parent function is y equals x squared, which is a parabola. So here's the thing. If I think about this and this, I'd go, wait a minute, I need a third point. I gotta know where that vertex is. Well, look guys, y equals x squared would be right kind of like this. Y equals x squared minus 1 would take that lightly dotted parabola and drop it down 1. So it's like, aha. So this drops this vertex down 1. So there it is. And so it would not be this, because it's not a line, it's a parabola. And there it is. So that's a little trickier. 2 points don't quite do it. You need 3. Now back to this one, y equals x plus 1. So I'm going to go over here, y equals x plus 1, make one of these handy dandy little charts. Left-hand boundary is a 2, but be careful, this is greater than, so that's going to be an open circle. And then 10 is less than or equal to 10, so that's a 10 with a filled in dot. If I plug the 2 in, 2 plus 1 is 3, put the 10 in, 10 plus 1 is 11. Now this is an open dot, so if I went and found it, 2 comma 3, I'd go 2, 3. And I see that it's already filled in by the parabola. You might say, well, it's supposed to be open. Well, the parabola overlaps it, so that's actually filled in, even though this one's open. So that's the point. And then 10, 11, I think that's 10, and I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's an 11. Sorry about that, you guys. So 10 would be right here, I think. And that's closed in because of that little dot. And then I connect the dots, and there's your piecewise function. Now we got to ask some questions. What's the domain of the whole function? Well, how far left does it go? Well, that point right there is this point, -10, 29. So how far left does it go? -10. So I know, and it's a filled in circle, so it's bracket. How far to the right does it go? Well, it's that point, which is 10, 11. Which one of these is considered the right? The 10. So this is 10, 11. So I want to know how far to the right it goes. It goes 10. And it gets there. It's a filled in circle. Now what's the rate of change of the entire function? That means I need to go from the far left point, which is right here, to the upper right point, which is there, and just assume there's a line that connects the dots, and you could go ahead and go rise over run, or use the formula. Now I'm going to go ahead and use the formula for the grand finale, and here we go. Because this one's on the far left, I'm just going to call this -10, -29. I'm going to call that my x1, y1. And this one up here is my x2, y2. All right. And we're going to plug them in. So here we go. Y sub 2 is 11, minus y sub 1 is -29. And then x sub 2 is 10, minus x sub 1, which is -10. And so that's 11 plus 29, which is 40. 10 minus a negative 10 is actually plus, so that's 20. 40 divided by 20 is 2, so that would be my slope. And that, I believe, finishes our Unit 1 quiz review, 1-1 through 1-3. See me if you have any questions.